Alright, continuing on this Maygay stuff, this is the power supply that the owner of this board sent. And he sent a couple of spare boards here as well. Now he's spotting with these dinos, this one is cutting out on the 12 volt, it's actually blowing fuses on the 12 volt line. I'm not sure why, because there's no apparent shorts. But he sent a second board up, slightly different to that one. And that appears to be working very, very well. I'll just turn it on and refer you to here. Good strong 5 volt line. On top of that, 12 volt works as well. Now the way you test for 12 volt in these, it's a little bit, it's not very straightforward. If I just move that to there, you cannot just test the 12 volt line, right? You can't just move the lead over and check the line because nothing happens. What you have to do is, if you look, I've got that probe lead sitting in pin 14 in the power supply plug, and I've got that connected to lead. You have to ground pin 14, which is the relay control, like so. And we've got a good solid 15 volts, very strong 15 volts. So it should be 12 volts, but it's 15 volts because it's actually 16 volts, but that's because there's no load. But as you can see, the relay is working. Relay is working and 12 volt supply is working. 12 volt supply is strong. And the other lines are working as well. I've tested the V-Sense and the VMM, they all seem to be fine. So at the minute, the second power supply board, from what I can see at the minute, is perfect. I mean, this one's obvious issues. This one's not working. So it's slightly different from the normal Maygay design. It's got a non-standard regulator there. But this with the second board on it, this is working. So I think the next step is to plug his board in with my test card there, and we'll see what the board does. Right. The board's all connected up. I've still got my voltmeter attached there. No card on it. Still a strong 5 volt. So no 12 volt yet, but we've not got a card on. So let's put my ROM card on and see how we got on. Right, so power the board up and it doesn't start. Now, I've got my meter on the V-Sense pin and it's jumping about all over the place. It's not really doing anything significant. Although it's very slowly rising. Hold on a moment. We've got a bad capacitor on that line, I think. But it's going to stop it burning up because V-Sense is attached to the halt pin on the CPU, pin 40, which is stuck low at the minute. So the CPU is stuck in halt and it's not going to start. The way it works is you have a voltage divider on pin 2 of U28, and it sets pin 2 of U28 to about 2.5 volt, and then your V-Sense line should come in at about 3 or 4 volt into pin 3, and this little C11 here is a voltage comparator. So it's an operational amplifier, but it's set up as a voltage comparator, and if pin 3 rises significantly above pin 2, it will turn pin 7 high, which is attached to pin 40 of the CPU over there. So if you look at the meter, we have a power supply fault on the V-Sense line. Now I've tested the other lines. I think the 12 volt unregulated, the 12 VMM as it's shown on schematics, is okay. I think the problem with this power supply is just the V-Sense line. And the way that meter's jumping about, it looks like a bad capacitor. So I'm going to see what I've got to put in its place. Let's maybe take the capacitor off that board, and I've got another spare board as well, but yeah, we'll have a look at this and see what we can do. So here's something interesting. I've got it disconnected just now, and it's hard to see, but I've got a schematic for the power supply here. V-Sense comes from D4 and C8, and then out of pin 8 now. I've checked the solder joints down there, all fine. I've checked D4 and I've got 11 volts one side and just over 10 the other. But here's a little discovery I made. I've got the board unplugged, but I've got the meter into the V-Sense pin. And we're getting V-Sense. We're getting the 10.5 to 11 volts. But we don't get it when it's plugged into the board. So do I have a board fault? Or do I have a bad C8 there? I think what I might do is take C8 and D4 off of here and put it in here and see what's going on, because that's weird. And in addition to that, I dropped the board, don't worry, it doesn't do any harm. In addition to that U28, yeah, that's U28. That U28's been, wasn't it? No, it's the other one. No, I thought U28 had been worked on, but it's not. That's U46. U28 looks untouched, but there's something odd going on here. Ignore the noise in the background. Like I said in previous videos, this is a house, not a workshop. There's something odd going on here. I've either got a board fault where someone's dragging the voltage down, or I've got a bad capacitor here which is failing under load. So let's see. Right, so when you get this board out of here, look, quite simple. You disconnect this, and then you've got these two nuts here, and you've got that nut there. So I've worked a few of these in the past, and I find them with the standoffs broken, or these nuts are all chewed up, or this nut here is chewed up, because people are using pliers and spanners and scissors and God knows what else to get the bolts out. I'm guilty of it myself. I mean, who wants to spend money on what you think is just going to be on one repair? But yeah, these days I've done it well, made life easy for myself. Got a couple of nut drivers. Gets these out a lot easier, gets them out in a few seconds, and it saves your knuckles against this metalwork as well. So, right. We'll get this out. What should we, and we'll change this C8 over, which he's living right there. And we'll see you shortly. Bang. There we go. Right. We're back on the V-Sense line there. Let's see if we made the difference. Right, so obviously that didn't solve our issue. Give me a second here. See if we can zoom in. Right, so we saw from a few minutes ago, we still had a very slow rising and low V-Sense line. So I was looking at the schematic here and I was wondering what else is on the V-Sense line that can drag it down. Well, nothing really. But V-Sense line also shares the supply with the main 12 volt line. And this big chunky capacitor here. So it's on a different line. We've got a strong 12 volt line coming out here. But just for shits and giggles, I changed it. Yeah, well, it's not bad. Maybe it's shut up at the top. Yeah. We'll see. Still something not right. Yeah, Matt? That's strange how that's doing that. Investigation continues. Right, so we still have a problem. Changing this hasn't fixed it. I didn't think it would because it comes off a different line. There's that capacitor there, C7. And if you follow this, it comes right off the 11 volt coil, through the bridge rectifier, and there, and out to the relay. The problem I'm having is down here at C8. If we follow this along, that comes off the same 11 volt coil, but it goes through two diodes here first, and then through D4. So if I fire this back up, put this somewhere where we can sort of see it. So I'm checking voltages. But here, and if I go, that's D2 diodes here, D2 and D3. So if I go on D2, I get 5 volts there. If I go on D, something a tricky to see. I get 5 volts there. Wonder if that's a cracked solder joint maybe. I'll reflow that. If I go here to D4, can you see? I'm on D4, hard to do one-handed. I've got 10 volts there, right? So let's go on the other side of them now. This is D2. 10 volts. That's D3. 10 volts. See? D4, however, is all over the place. But D4 comes off of these two. Come on, focus. D4 comes off of these two here now. Looky there on the camera, it looks like I may have a cracked solder joint there. What I'm going to do is I'm going to replace this D4 anyway, because D4 comes right off the end of D2 and D3. And I've got 10 volts there. And if I go to the other side, now it wants to work. There's something wrong with this D4, I think. Because I've got a solid voltage on one side of it, and then the other side of it is all over the bloody place. I'm going to replace this D4. Okay. Replace D4 there, and let's see. That looks a bit different. Okay, now here's the test. What I was getting before was when you turned it off and then turned it back on, it wouldn't come back up. I think that might be fixed. It is rock solid. Turn it off again. Let it drop lower this time. Yep, that looks like that's fixed. So it was that D4 by the looks of it. Maybe a combination of D4 and C8. But so I tested this little bugger, and I thought at first it was good because it was giving me a good reading, but then it wouldn't read and then it would read. So I don't know if maybe it's got a cracked leg that I can't see, or if it's just bad. I'm still not entirely sure if we didn't have any more cracked solder joints in there, but it looks like we might have solved our mystery why this was going wrong. So what we've got to do now, we've got to put the board back on it and see what's happening. Right, so board all connected up. Let's see, good 5 volt. And pretty tricky to do this one-handed. You can just see that there, we've got a high on the hot pin now. So, boom. She works. So there's nothing to say that that power supply is not fully working now. Was just a bad capacitor and a shorted diode. I do like that test ROM. I don't know what else that test ROM's supposed to do. You can get a Maygay test rig back in the day, but I wonder if that test ROM's got other features besides just flashing those lights. But yeah, it's all working. 5 volts nice and strong. We know that 12 volts strong. Obviously can't test lamp voltages and stuff like that now. But yeah, she's alive. So it was just, yeah, it was just that. This was probably leaking as well. This might have even been bad in taking this out, but it was just this diode being flaky, sometimes working and sometimes not. Because I replaced the bugger and we're up. So this can now go back to its owner for a full test. Just one thing I'd like to say though. I did actually have to do a double check because there's meant to be some sort of heat transfer paper or insulator paper or something under that tab. I'm sure there's a bit of blue paper missing. So I would just keep an eye on that, or maybe put a little bit of thermal paste on that tab just to help the heat transfer. I did actually replace that regulator because the legs on the one in it were pretty borked up. And it's not a fantastic fit, but yeah, it's in. It's in, and it works. So, just so then note, the owner of the board asked me, what do we need a V-sense line for anyway? Well, it's to protect your board against mains failure so you don't get the likes of what you used to see when your batteries were going flat in your toys. I'll show you what it does. What it does is, give me 1 second here. Until I get the appropriate part. Right. This will do. I enlarged this sometime back when I was working on another Maygay board. What was it, about 5 years ago or something. Okay, so to cut it short, V-sense just protects your board from doing weird stuff. Like what you would see if your batteries were low in your toys. You don't want the game to start acting weird when you're playing it. It's not good for the operators, it's not good for you, and you potentially lose money and stuff like that. Anyways, this is an LM311, and it's what you call a voltage comparator. Now what they do is, they have a solid 5 volt supply coming through, and it comes into pin 3, which is the inverting input of this comparator. And what they do as well is they have the V-sense line comes from the power supply and goes into pin 2. That's the 12 volt line that we just restored recently. The idea behind it is that if pin 2 is higher than pin 3 by a fair amount, pin 7 goes high, which is connected to the whole pin of your CPU, and the game runs and everything's happy. But say the voltage drops, say you have a power dip or a power cut or something happens to the power supply and the 12 volt line goes away, this would then become lower than this. Maybe not for very long if you get a power cut, but it's low enough that this will go low and your CPU will stop, and then the other half of the reset circuit will bang the board into reset. It stops you being able to use the game when it's doing weird things because of low voltage. That's all it is, it's just a protection for the board. You see that this type of logic here only has a very fine operating window. It can only operate around about, I think, 4.5 to just over 5 volt. And if it's lower than that, then it just doesn't work properly. So they need a way of stopping the board running if the voltage is lower than that. That's all. Anyways, this is going back to its owner for a proper test now. And a machine, it may have to investigate something to do with hoppers. But now he's got a working power supply to go from. Then, yeah, it should be alright. Alright? Yeah, I don't know if it's but yeah. Get a bit of thermal paste or a bit of that heat transfer paper on that. I'm positive that's missing. Should be a bit of blue paper there. I'm sure I could see that. I've seen that before in all Maygay power supplies. A little heat transfer pad. But the owner can figure that out. Don't have anything like that here. But anyways, that's a wrap for now. Feel free to like the videos and subscribe to see more flashy lights.